In this video, we are going to be doing one of my favorite parts of each section, and that is solving equations. I love doing that. And we are solving rational equations, so stuff with fractions. Just before we get into solving, it's important for us to identify when we're doing specific things. So in the last section, we were working on expressions like this, and all we were doing with these expressions was simplifying them. So in this particular one, I think we came out to x squared minus 9 on the bottom, and then we had some stuff up top. But all we did was simplify or re-express this original expression. When we get equations like this one, we're solving. So we want to find out what value can I plug in for x that'll make this statement true. So to do that, here's a few steps that you can do. So first, you use the I hate fractions rule. I named it that. I don't mind fractions, but typically students say this. Anyway, the rule says that if you're doing an equation, has to be an equation, can't be an expression. If you have an equation, you can multiply every term on both sides of the equation by a lowest common multiple. Then once you've done that, simplify what you have, and then solve the equation like you always do. And again, at the end, make sure you check your answers. Let's try one. So here's one. I need to get a lowest common denominator. So 4, 2 times 2, 8, 2 times 2 times 2, 12, 2 times 2 times 4. So the LCM looks like 3 2's is the largest number of 2's. And, oh, this isn't a 4, it's a 3. And a 3. So 2 times 2 times 2 times 3. So my lowest common denominator or multiple is 24. So now I'm going to take this original equation, so the 3/4 plus the 5/8 is equal to the x over 12. And I'm going to take each term, this one, and multiply it by the lowest common multiple, 24, and by 24. Notice I'm not really getting a common denominator here, and the purpose of this rule here is actually to get rid of all denominators. So I'm not getting a common denominator, but I'm using what would have been the common denominator to multiply each term by. Okay, so 4 into 24 goes 6, 6 times 3, 18, plus 8 into 24 is 3, 3 times 5, 15, is equal to 12 into 24 goes 2, 2 times x is 2x. Add these is equal to 2x, divide both sides by 2, and my final answer is x is equal to 33 over 2. Now, to go back and check, let's just do that quick. So they're saying that the value for x here is 33 over 2. That's sort of a hard fraction, but maybe one thing you could do is just on your calculator do this. Go 3/4 plus 5/8, see what it comes out to. I think it comes out to 11/8 or something like that. And then do the same thing with this side. Do 33 over 2 divided by 12 and see if it comes out to the same number. I'm hoping it comes out to the same number. Okay, so that's the I hate fractions rule. Now what I'd like to do is just show you 4 or 5 different questions where we use that I hate fraction rule. Okay, so here's another one with numbers. So I need to get a common denominator. Looks like it's going to be 24 again. So x over 4 minus x over 6 is equal to 1 over 8. And then notice that I'll take, and I left space there, so that I could take each of these and times them by 24. Sometimes in the question you'll see them where they take this whole thing like this and multiply by 24. And again, it's in an equation, so it's a little funny, but you multiply everything inside by the 24. I like doing it this way, but do whichever way works for you. 4 into 24 goes 6, so this will be 6x. 6 into 24 goes 4, so this one will be 4x. is equal to 8 into 24 goes 3. 3 times 1 is 3. 6x minus 4x is 2x is equal to 3. Divide both sides by 2, and you get x is equal to 3 halves. Again, if you plug it back in there, use your calculator. 3 halves divide 4, minus 3 halves divide 6, and see from that if you actually come out to 1/8. If you do, then you know that your answer is right. So another one. Ooh, my denominator is now some x's. If you wanted to do your LCM over here, so 2x breaks into 2 times x, and just x, of course, is an x. So my LCM, there's a C in there somewhere, is I need a 2 and I need 1x. So my LCM is 2x. So I'm going to take this term plus this term. And again, don't revert to trying to get a common denominator. We found an LCM. Now we take each term and multiply them all by 2x, 2x, 2x. Here the 2x's cancel, so I'm left with a 1. Plus, here just the x cancels, so 2 times 1 is a 2, is equal to 2x times 12 is 24. So 1 plus 2 is 3 is equal to 24 x. I forgot my x there. Gee, I'm forgetting a few things today. And then divide both sides by 24. So it'll be 3 over 24, or x is equal to, if you simplify, 1/8. And again, good idea to plug that in right there and see if when you try that on your calculator, or you figure out longhand, if one side is equal to the other side. Okay, let's try a couple more. Oh, here's one where the binomials on the bottom. These ones, my LCM here, will be just x plus 2. So I'm going to take this side and multiply it by x plus 2, and I'll take this side and multiply it by x plus 2. So the x plus 2's cancel here, x plus 2's cancel here, and so my equation is x is equal to 4. So what number can I plug in for x to make this statement true? Well, x will be equal to 2, of course, so positive 2, but also a negative 2. Because if you take negative 2 and square, it still gives you a positive 4, which is on that side. So this question here actually came up with 2 answers. Now, interestingly enough, with this one, maybe I'll check this one just to show you that. So say if I take x as positive 2, if I were to put a 2 in here, let me just erase that. If I were to put a 2 right in there, I'd get 2 plus 2 is 4. All's good with that. Well, maybe I'll figure that out. If I put a 2 in here, 2 squared is 4. 4 divided by 4 is going to be 1. And on this side, again, if I put a 2 there, 2 plus 2 is 4. 4 divided by 4 is 1. Therefore, a positive 2 for sure is correct. And now let's check a negative 2. If I put a negative 2 in there, negative 2 plus 2 is 0. If I get a 0 on the denominator of a rational expression, then that doesn't work. I stop it right there. So x is equal to 2, but x cannot be equal to negative 2. So my only answer for that question is positive 2. Okay, here's another question down here at the bottom. X plus 1 over x is equal to 2. LCM, both of these just have a 1 there. And so the LCM will be x. So I'm going to take x and 1 over x and 2. I'll take each of those and multiply them by an x. Multiply them by x. Multiply by x. Notice it's the same concept every time. X times x is x squared plus x divided by x is 1. 1 times 1 is 1. Is equal to 2 times x is 2x. Now, going back to section 5.6, I think, or solving quadratic equations. Here I have a quadratic. It's an x squared, an x, and a number, but they're not in the right order, nor are they on the right side. So I should rewrite this as x squared plus 1 minus 2x equals 0. I still don't have it in the right order, so it should be x squared minus 2x plus 1 is equal to 0. So now I've gone from a rational equation up here down to an equation that is a quadratic one. To solve quadratic equations, we factor, and then we use the 0 property. Two things that multiply to 1 add to negative 2, I think are minus 1 and a minus 1. And so either x minus 1 is equal to 0, or I guess the same thing. In either case, x is equal to 1. Now, if I put that back in my equation here, whoops, let's go to the original one, right here. So it would be 1 plus 1 over 1. Does that equal 2? So 1 over 1 is 1, 1 plus 1 is 2, yes. So this is that's my check right there. Therefore, this answer is correct. I probably should show you a proper way to do checks, or a good practice. A good practice to do a check is to rewrite the original equation and then use brackets and plug in what you think the answer should be for each value of x. And then go ahead and solve, and you're always wondering if this side is equal to that side. If it turns out in this case that they are true, then that means the one that you plugged in is correct. Let's try one more question. I think I've got one more. Yep, this one right here. Okay, I see a binomial oh, this is a quadratic. That's a difference of squares. So I can rewrite this 4 over x minus 2 plus 1 over x plus 2 is equal to 26 over, let's do that as a difference of squares, x minus 2, x plus 2. So when I look at the expression, I've got an x minus 2, an x plus 2, and then I have both of them there. So the LCM has to be both of them combined. So x minus 2, x plus 2. So I'm going to take this one, and I'm going to take this one. And this is where it gets a little bit long. 26 over x minus 2, x plus 2. Okay, I've got to take each one of those terms and multiply it by this LCM. So x minus 2, x plus 2, x minus 2, x plus 2, and x minus 2, x plus 2. So I'm multiplying this guy, and this guy, and this guy. In the first one, the x minus the 2's cancel, so I'm left with 4 times x plus 2. There's the 4 times x plus 2. Typically, you write the number by itself first, and then the binomial. Plus, the x plus 2's cancel, so it's 1 times x minus 2. 1 times x minus 2 is equal to, and the last ones both cancel, so it's just 26. Now I've got an equation with only, there's no fractions in it, so I can use my normal stuff. So 4x plus 8 plus x minus 2 is equal to 26. 4x and x would be 5x. Since there's just x's here, I'm going to take these numbers and move them to the other side. So 8 take away 2 is 6. If I take it to the other side, it becomes a minus 6. Therefore, be 26 minus 6, or 20. Notice I did a couple of steps there, and this is back to stuff we've done in the past. If you need more steps, for sure put those in. But just solve this as you normally would. Okay, and then 5x is equal to 20, therefore x is equal to 20 divided by 5, or 4. Let's just quickly go up and check, and hopefully that would work. 4 take away 2, that doesn't give me a 0 on the bottom, so that's good. 4 plus 2 doesn't give me a 0. 4 squared is 16 minus 4. That doesn't give me a 0 either. I just quickly check to make sure I don't have a 0 on the bottom, but you probably should plug the number in to each one and figure it out. Often using a calculator is valuable. This is nice to check too, because you'll know you'll be right on an exam. Okay, so that is how we solve rational equations. And the important thing with this one is the I hate fractions rule. So if you have the I hate fractions, use that rule, multiply every term by a lowest common multiple, the fractions go away, and you can solve equations like you normally do. Okay, hopefully that helps. Try a bunch of questions.